The A6M5 was powered by a Nakajima Sakai 21 engine. This was a 14-cylinder air-cooled radial engine arranged in 2 rows of 7, with a total displacement of 27.9 litres. It produced 1,130 horsepower at takeoff, dropping to 1,100 horsepower at 9,350 feet and 980 horsepower at 19,685 feet. The Sakai 21 drove a 3-bladed all-metal propeller manufactured by Sumitomo under a license from the American company Hamilton Standard. The blades had a diameter of 120 inches and could change pitch in flight, ranging from 29 degrees at fine pitch to 49 degrees at coarse pitch. The Sakai 21 used a downdraft carburetor. Air entered from the top of the engine and was channeled down to the cylinders. This was a distinctive feature of the A6M5. Since the carburetor was positioned at the top of the engine, the air intake was moved from the bottom to the top as well. To maintain power in thinner air, the engine used a 2-speed centrifugal supercharger. This was a spinning impeller driven by a gear connected to the engine shaft that compressed incoming air before it entered the cylinders. The defining feature of the A6M5's engine setup was its exhaust system. The engine had 11 individual exhaust stacks mounted directly to the cylinder heads, 6 on the right side of the cowling and 5 on the left. These short pipes expelled hot exhaust gases backwards at high speed, giving the plane a small extra push of forward thrust. Combined with the short wingspan, this allowed the A6M5 to reach a top speed of 351 miles an hour at 19,685 feet in level flight. The engine was cooled by a constant flow of air through the cowling. Adjustable flaps at the rear, often called gills, controlled how much air passed over the cylinders. The Sakai 21 ran on 92-octane Aviation gasoline. The aircraft's total internal fuel capacity was 150 US gallons, stored in 3 tanks. A small 15.8-gallon tank sat in the forward fuselage, directly behind the engine oil tank and the steel firewall. This meant that the pilot and the fuel tank were in the same compartment. Space available in the fuselage was limited, and the Sakai 21 had a high fuel consumption rate. To compensate this, the majority of the fuel was carried in the wings, in 2 tanks holding a combined 135 US gallons. In the standard A6M5, none of the internal tanks were self-sealing, and none had armor protection. A single hit from an incendiary round could ignite the fuel and turn the aircraft into a fireball. This was the most dangerous consequence of the Zero's extreme weight-saving philosophy. The Zero's standard operational range was between 963 and 1,193 miles, depending on altitude and mission profile. This was one of the aircraft's few constant advantages over faster and better armored American fighters. But that range came with very real tactical limits. On missions 650 miles from base, pilots were left with only about 1 hour of combat time over the target. Bad weather or a navigation error on the return flight could mean running out of fuel over open ocean. To extend its range, the aircraft could also carry a drop tank under the center of the fuselage, holding an additional 87 gallons. The cockpit of the Zero A6M5 was designed to be simple and functional. But when captured planes were inspected by US pilots, they found the cockpit extremely cramped. Legroom was so tight it made the operation of the rudder pedals and brakes difficult. The canopy was a 3-piece design made from plexiglass. There was no armored glass to protect the pilot from gunfire. The canopy consisted of a fixed front windshield, a sliding middle section, and a fixed rear panel. This layout gave the pilot an excellent view in almost every direction, with very little visual distortion. The middle section slid backwards on rails to let the pilot climb in and out. A locking pin lever on the inside left of the forward frame held it shut. The pilot sat in a duralumin seat hung on 2 metal arms. The height could be adjusted mechanically, and pilots would often raise it during takeoff and landing for a better view over the nose. Because the aircraft was designed for extreme lightness, there was no cockpit heater. Even the seat cushion was removed. The main instrument panel held 15 gauges. The center cluster contained the artificial horizon, turn gauge, and radio compass. The left side had the airspeed indicator, altimeter, clock, mixture gauge, and a navigation gauge. The right side was dedicated to engine monitoring and vertical performance, with gauges for vertical speed, intake manifold pressure, fuel pressure, oil temperature, engine RPM, and cylinder temperature. Below the main panel were fuel gauges for the wing and fuselage tanks, as well as the engine main switch, the fuel injection pump, the ignition plug charger switch, the oil cooler shutter control, and the oxygen system controls. Mounted on top of the panel was the Type 98 reflector gun and bomb sight, used for aiming both the machine guns and any bombs the aircraft was carrying. This was a Japanese copy of the German Revi C2 sight. An internal lamp and lens system projected a reticle circle onto a piece of reflector glass, which the pilot looked through while lining up his target. A movable coloured filter could be swung into place when flying into the sun, so the reticle stayed visible against any glare. If the optical system failed, the pilot could fall back on a mechanical ring and bead backup sight. A small padded cushion was fitted to the rear of the device to protect the pilot's head during a rough landing. On the left wall sat the throttle handle, painted blue for quick identification. The mixture control lever and propeller pitch lever were both nearby. The elevator trim wheel was also on this side. The right wall held the landing gear lever painted red, the flap control lever, an emergency hydraulic hand pump, the seat adjustment lever, and the arrestor hook handle to be used for carrier landings. The radio control board was also mounted on the right wall. The control stick was a simple vertical lever mounted on the cockpit floor, with no buttons or triggers of any kind. The rudder pedals at the pilot's feet were adjustable for leg length. The pilot engaged the wheel brakes by rocking the tops of the pedals forward. Before starting the engine, the pilot worked through a series of checks. He moved the control stick and rubber pedals to make sure that they were free. He confirmed the fuel levels and set the fuel selector to the desired tank. He then checked the hydraulic pressure gauge, since the system needed to be at full pressure to operate the landing gear and flaps. To start the engine, the pilot used the manual fuel injection pump to prime the cylinders with fuel. He then set the engine main switch to engage the ignition. Once the engine fired, it often produced a burst of white smoke from the exhaust stubs. The pilot monitored the oil temperature and cylinder temperature gauges as the engine warmed up, and adjusted the cowl gills using a handle on the right console to control the heat. When the engine reached operating temperature, the pilot prepared for takeoff. The mixture lever was moved to rich. The propeller pitch lever was set to fine pitch for maximum RPM. He adjusted the elevator trim and set the flaps slightly down using the hydraulic flap lever. For a straight takeoff run, the pilot locked the tail wheel in the center position using a control in the cockpit. He then closed the sliding canopy and secured it with a locking pin lever. When he received clearance, he released the brakes and smoothly pushed the blue throttle handle forward. The Zero A6M5 was known for its remarkably short takeoff distance. It often needed less than 330 feet to become airborne. As the speed built, the rudder became effective, and the pilot used it to keep the aircraft tracking straight down the runway. When the speed reached just over 77 miles an hour, the plane would lift. Once the aircraft lifted off, the pilot moved the landing gear lever to the up position. He confirmed the gear was retracted by watching the mechanical indicator rods on top of the wings drop level with the wing surface. As the gear came up, the aircraft became slightly nose heavy. and the pilot rolled the elevator trim wheel on the left console to compensate. The A6M5 climbed smoothly. It could reach a maximum altitude of 38,517 feet. At low speeds, the controls felt light in the pilot's hands, and the aircraft turned with agility. In a typical engagement over the Pacific, A6M5 Zeros would approach an American fleet in two groups. One group would act as an escort, while the other carried out the main attack on a one-way kamikaze mission. If a division of F4U Corsairs dived in from above, the escorting Zeros would respond at once by turning hard to disrupt the attack. The A6M5's light controls and strong low-speed maneuverability allowed it to pull into a steep climbing turn, sometimes followed by a snap roll or a quick reversal. That made it harder for the American pilots to hold the Zero in their sights during the first pass. Corsairs would rely on their speed to extend away and climb back into position for another pass. A Japanese pilot would hope that the Corsair would lose too much speed in the turn, and the Zero pilot could then use the opening to fire his 20mm cannons. During close combat, the Zero pilots could rapidly switch to the nose-mounted machine guns. The Japanese ace, Saburo Sakai, later said, 70% of my kills in fighter versus fighter combat were made with 7.7mm machine guns. While the escort group kept the American fighters occupied, a second group of Zeros could approach the American fleet from another direction with a 550-pound bomb mounted under the fuselage. They usually flew about 30 feet above the waves, low enough to stay below the horizon of shipborne radar. Once the fleet came into view, the kamikaze pilot would gain a little height, then roll into a dive towards a carrier or another major warship. During the dive, a kamikaze pilot would often shout, "Banzai!" It was a short version of the Tenno Heika Banzai battle cry, meaning "Long live His Majesty the Emperor," or 10,000 years for the Emperor. The aim was for the bomb to penetrate the deck, while the impact of the fuel-filled aircraft added to the destruction. If the attack hit home, fires could spread across the flight deck and into the hangar spaces below, where fueled aircraft, ammunition, and stored ordnance would make the damage far worse. Of course, not every Zero pilot flew a kamikaze mission. Standard combat engagements continued throughout the war. To land, the pilot had to first reduce speed. He throttled back the engine using the handle on the left console. Before reaching the final approach, he made sure that the tail wheel was either unlocked for ground steering or locked straight for a stable landing run. When the aircraft reached the correct speed, the pilot moved the landing gear lever to the down position. The main landing gear and tail wheel extended hydraulically. The pilot then lowered the split flaps using the control lever on the right console. The standard approach speed was around 100 miles an hour. The Zero held a stable flight path on approach with very little tendency to drift off course. As the aircraft neared the runway, the pilot would begin to flare his plane, reducing speed to around 75 to 80 miles an hour. Touchdown speed was typically between 65 and 70 miles an hour. The landing itself was generally smooth. After touchdown, the pilot applied the wheel brakes. He steered on the ground using rudder pedals and the steerable tail wheel. Because the A6M5 had no parking brake, ground crews had to place wheel chocks under the tires as soon as the aircraft came to a complete stop. The pilot then opened the cowl gills fully to let the engine cool. He would cut the ignition, pull the throttle and mixture lever back to their minimum position, and close the fuel tank selector cock. After switching off the battery and electrical systems, he unlocked the canopy, slid it back, and climbed out onto the wing. The A6M5 Zero remained the backbone of the Imperial Japanese Navy's air defense during the final years of the war, and it saw action in every major theater of operations from autumn 1943 until the surrender of Japan. Although the A6M5 could still easily turn inside its opponents at low speed, that agility came at a price. Its skin was dangerously thin, and Allied forces sometimes called the Zero a paper aircraft. With little armor and no self-sealing fuel tanks, even a short burst of incendiary rounds could rupture the tanks and ignite the fuel. And yet, For all its limitations, the A6M5 remains one of the most recognizable fighters of the war. Thank you for watching. If you spotted any errors, please let us know in the comments. We're looking to continuously improve. If you want to look inside more iconic World War II aircraft, then check out this video about these incredible planes.